All right, this is problem 10.5.45, and they give us Cassandra needs to research 4 of the animals in the chart below for an assignment, and we want to know how many ways can the 4 animals be chosen so that at least one of the animals is a fish. And I didn't write out all the animal names because it was going to take some time and it's not really important. What's important is how many animals were there in each category. Okay, so this is what they gave in the chart in the problem. There were 8 animals in the mammal category, 5 in reptile, and then so on. Okay, so the key in this problem is they use the words at least one. So we have to think about what that means. So if you have at least one, then you can have 1, or you could have 2, or you could have 3, or you could have 4. And so you actually need to calculate, you actually have to count each of those situations separately and then add them together. Okay, so I'm going to write this out for you so that it'll make some sense. So we want at least 1 fish. Okay, so that can occur in a number of ways. We could have exactly 1 fish. Okay, so that would mean that we would have 1 fish and then 3 of some other of these types. We could have exactly, and actually I'm going to use the word or here. We could have exactly 2 fishes, or yeah. And or we could have exactly 3 fish, or we could have exactly 4. Okay, and so like I'm saying, we actually need to count each of these situations separately, and then we're going to add them together. These ors right here mean plus signs for us. Okay. All right, so let's go ahead and calculate exactly 1 fish. So I'm trying to count 4 animals altogether, but I want exactly one of them to be a fish. So if this one's going to be a fish, then, and these are combinations because the order doesn't matter in how you choose these. So this would be a combination of, I have 6 fish to choose from, and I'm just choosing 1 in this scenario. So the way to count the fish portion of this is a combination of 6 things taken 1 at a time. And then the other 3 have to come from something that's not fish. If it's a fish, then I don't have exactly 1 fish. Okay, so I can draw for these next 3, I can draw from any of these other categories other than the fish category. So if you count these up, there's 10, and then 8 and 9 is 17. So there's actually 27 different animals to choose from that aren't fish. So this is going to be a combination of 27 things to choose from, and I'm choosing 3 of them. So this right here, combination of 6 taken 1 times combination of 27 taken 3, represents how I would count exactly 1 fish. Okay, and like I said, we need to add to that exactly 2 fish. So the situation for exactly 2 fish would be a combination of 6 taken 2, so that's we're choosing 2 fish from the 6, and then we're still choosing from 27, but this time we're choosing 2 of them. Okay. All right, and then for 3, you can kind of see the pattern here. So for 3 fish, this is a combination of 6 taken 3, and we have 1 left over chosen from any of the others. So that's a combination of 27 taken 1. And then 4 fish here is just going to be a combination of 6 taken 4, and plus signs between these. Okay, so now you actually have to calculate all of that. I'm not going to go through and do the calculations there. You can just use your calculator to calculate each of these. I'm going to actually write it a little bigger so we can see what's going on here. So this is a combination of 6 taken 1 times a combination of 27 taken 3. So you're going to do that. You're going to actually do each of these, and then you can add the result together. Okay, so calculate this, calculate that, and then that, and then you're going to be adding them together after you've done those calculations, okay? And I'm assuming that at this point we know how to do those combinations, which is why I'm not writing it out for you. But, if you're just using your calculator, if I want to take, a combination of 27 things, taken 3 at a time, and you can just plug it in, and, for that particular thing, I'm getting 2,925, okay? All right, so that's it in this problem.